What is up, Flutter devs? After the last processing video that I put out, a colleague reached out to me and said, why are you messing with the processing APIs? In other words, why are you giving the processing APIs in Flutter a different contract than the one in traditional processing? And I said, well, why exactly do you need the same contract that exists in processing? And he said, well, because then you could copy and paste the code. You could copy the code from the Java sketch into a Flutter sketch and it would just work. And hey, fair enough. That is a possible value proposition. I wanted to take a few minutes today before I get into any further videos and kind of explain my rationale behind these APIs, why I'm taking the angle that I'm taking, and also show you that even though right now we aren't creating the same APIs, there's no reason that we can't eventually wrap what we're creating with the traditional APIs to facilitate some of the copy and paste. So let's jump into some code and let's just look at a little bit about my rationale for why I'm doing what I'm doing with these APIs. And as always, if you agree or disagree vehemently, you can go down into the comments and let me know what you think, but I'll tell you what I'm thinking, okay? So let's come back here to the desktop and let's bring up the usual specifications for processing. And here I have, let's just go to the background call. One qualifier here, I'm recording this video after I've already done a number of processing videos. So you're going to see this one at a point in time where actually I'm recording this after the next 4 or 5 videos. So those are already set in the pipeline. They're going to be what they're going to be. But what happens after that could change based on responses to this. But I think in the last video, we implemented the background call. As a quick reminder, the background call fills the background, fills the entire space with a color or an image. Now, let me remind you about what the Flutter API for this looked like. This right here was our implementation of the background call. We take in any given color. This way you can base it on RGB values, RGBA values. You can use hex, you can use integers. You have full control over what you mean by color instead of passing a bunch of different integers. My point here was that let's say you're not trying to copy and paste code that already exists. Let's say you're trying to learn how to do graphics, UI, or multimedia programming. Or let's say you're teaching how to do this programming. Well, let me ask you a question. If you're trying to teach somebody how to do this, is it easier to teach them with this line right here that I have highlighted, background color gray, or this line up here, background 51? Which one of these is likely to be easier to teach someone how to do and for someone to maybe discover on their own? In my opinion, it is clearly this one at the bottom, which specifies what the parameter means and then uses a type which is oriented towards the thing you're expressing, in this case, a color. But of course, this API down here at the bottom that I opted to define does not match the existing or traditional API for the background call. So currently, if you were to take any real invocation of background from an existing processing sketch, you would not be able to paste that into the Flutter port of processing right now and have it run. That is a legitimate downside to the approach. So again, the upside here is that we have an API that's much easier to read and to discover and to understand than the traditional API. The downside is that you lose the copy and paste ability. There are 2 things that I want to show you in this video today. The first one is I want you to see, again, take another look at this background function. I want you to see how simple it is. 2 lines of code. We change a paint color, we draw a rect. I'm going to show you what it would take to implement the traditional API. I'm going to show you how much more code it will require and how much more difficult that code is to read. So I'm going to give you a sense for why it is probably faster and more effective for us to build intuitive APIs right now. But the second thing I'm going to show you in this video is that we can, even if we create intuitive APIs first, we can still create the traditional APIs second. It doesn't need to be an either or situation. It could be one and the other. So let's take a look. Now here's our goal right now. This is these 1, 2, 3, 4, 5, 6, 7 variations of the same call. The question is, what would it look like for us to implement this in the Flutter port for processing? If we had solved this problem with the same API, what would it look like instead of what we actually did? Let's go find out. You'll see that I have these to-do comments here. This is just me putting in the code what we need to facilitate. Every one of these calls that you see in a to-do comment is a legitimate call using the traditional API. Now in Java, this is largely a trivial thing to do because here's something we could do if we were in Java. Java, we could say void background int gray and implement that. And then we could say background int gray int alpha, and we could implement that one. And we could say void background int red int green int blue and implement that one. The point is, we could define one background invocation after the other. We could define the same, we could use the same name. It's called method overloading. We could define multiple methods with the same name, but different parameters. You cannot do this in Dart. Dart as a language does not facilitate method overloading. In Dart, the only tool that we have is optional and named parameters. So let me show you what it takes to solve this problem in Dart. Now, again, because we don't have method overloading, I'm going to have to comment out the existing solution for now. Actually, rather than comment it out, let me just call this, for lack of a better term, I'll call this background Flutter. It doesn't really matter that none of this work here is final. We're just investigating. But now let's declare a background function and let's figure out what it would take to truly implement the traditional API. Well, right off the bat, we know we have to support an int for gray. Let's see, okay. It's still complaining about the name here because I have extended sketch up here. Let me get rid of that. I'm gonna have to make some changes here for the code to compile most likely. Nope, all right. So we can't, for now, we can't use this class as a sketch because we no longer extend the machinery we need, but I can still show you what I need to show you here in terms of what it would take to implement this. We now have a background function or background method on this traditional sketch class, and it takes an integer for gray. But it also needs to be able to take an integer for alpha. And clearly we don't always need to take an integer for alpha, right? We could just take gray or gray plus alpha. Well, the way that we accomplish that is we create an optional parameter here called alpha. This accomplishes the first two situations that we want to facilitate, background 51 and then background 51, 255. Then we get to RGB, and now we have the first really interesting situation. This third call, this RGB call, is an integer for red, an integer for green, and an integer for blue. Well, we are taking two integers already, so we could just add a third optional integer for blue. But wait a second. If we take in a blue, then the first one isn't gray and the second one isn't alpha. It turns out that the role that each one of these parameters plays might be completely different based on the particular collection of them. Meaning, in other words, we can no longer afford to give these things names that mean anything, and instead we're going to have to go with something like parameter 1, parameter 2, parameter 3, and we know that in the case of RGB plus alpha, we need a parameter 4. Okay, so this signature now facilitates the first 4 calls. We no longer have parameter names because we don't know necessarily what role each one of those parameters is playing. But technically, we're taking in 1 required integer, 3 optional integers. We can technically invoke all of the first 4 of these calls. But what about the 5th one? The 5th one is not 3 integers. The 5th call is 3 float values. Float. In this case, we need to go from int to num. Num is a type, numerical, short for numerical or number maybe, but I believe it functions as a supertype for both double and integer. It's possible that any of these are all integers or all, well, not floats in this case, but doubles, because Dart doesn't have floats, it just has doubles. So now we've lost the names of all of our parameters, and we're starting to lose the types. And there's still one more that we have to facilitate, which is this call right here, which takes an image in the first slot, meaning now we're flat out dynamic. We don't even know what the first parameter is. This is what our signature looks like. Are you getting a sense for why I didn't think this would be the most effective way for us to get started here? And this is just the signature. This is just what's coming in. What do we do with these things? Well, it's going to be a bunch of if-else statements, frankly, and they could be ordered kind of any way you want them to. Let's just get started and see what happens. So if P1 is an int, and now I don't know the language rule here. What I want to say, what I'm thinking about is if we just go down the line and check all of them, assuming they're non-null, I'm sure this works fine, but what I'm wondering is if P2 is null, does P2 is int, will that blow up? I don't know. Let's just give it a try in this direction to see what happens. If the first 3 are all integers, then either we're in one of these 2 situations. We're in RGB or we're in RGBA. And then we could say background Flutter. This is our existing method. We could say color dot from ARGB. And then P4, we don't know if P4 is null or not. So we will say P4 or 255, and then we'll say P1, P2, P3. And that's about as clear as mud, right? If you were trying to read this code, how long would it take you to understand what it is we're saying here? We just have a bunch of P's, and now we're throwing them into a color, and P4 for some reason might not be there, or maybe it is there, we don't know. This is the mess of not knowing what you're given. This is the mess of cramming a bunch of things into one method when your language doesn't support method overloading. So if we're not in this situation, if P1 is not an integer, or P2 is not an integer, or P3 is not an integer, well, let's say if P1 is an integer, so we've passed the top situation. It's not RGB and it's not RGBA, but the first parameter is an integer. That then tells us that we must be in one of these top 2 scenarios, gray or gray plus alpha. In that situation, we can do something very similar as we did before. We will create a color, but now every component of the color is the same value. That's what makes it gray. It's the same amount of red, green, and blue that is gray. And again, P4 gets, this should be P2 in this case, the second parameter. If it exists for alpha, we will use that value. Otherwise, we will pass in 255. We've now interrogated the first 4 cases. Next, we can say, oh, sorry, this should be else if. And then we say else if P1 is double. Well, now we're in one of these 2 cases. These are the only places that floating point numbers are used are these 2 cases. Therefore, if even one parameter is floating point, it must be one of these 2 cases. Here, I think we're going to have to do a little bit of division on our color definition, because our color expects integers between 0 and 255. Here, we will go back to P4 for the alpha, and this time we'll actually do some calculations here. So we'll say if it's not null, then the alpha is what, P4 times 255 rounded. Okay, if the 4th argument is provided, we use that argument as a percentage out of 255 for the alpha. If it doesn't exist at all, we go with 100% opacity, which is 255. Again, the same behavior that we have up here above, except that we're dealing with percentages now. Then we have the red component. And so really we're going to do the same thing here over and over again with the rounding. We're going to have the first parameter times 255 rounded, then the second, then the third. Else implement image support. So as a recap, if there are 3 integers, if the first 3 parameters, or arguments I should say, are integers, we interpret the call as an RGBA call. If the first parameter is an integer, but it's not an RGBA call, then we interpret it as a gray plus alpha call. If it's neither of those, and the first parameter is a double, we interpret it as an RGBA percentage call. And if it's none of the above, we treat it as an image. Now, technically, this last part, there should still be another if statement. It should be something like else if P1 is image. The thing is, and not really image, it should be P image. There should be a special kind of image created for processing. I haven't implemented that yet. It doesn't exist, and so I can't actually code that if statement. It won't compile. Because then what we'd say is if it's none of the above, throw exception, bad call. That's the full implementation. But I haven't implemented p-image yet. Therefore, right now, I'm just saying else to do. But this is a background call that honors the traditional processing API. The parameters are named atrociously. Most of them are not required, and so you don't know what you're going to get. The closest we get in terms of specificity of the parameter is the num type, which means it could be a float, or it could be an integer or a double. And the first parameter is fully dynamic, meaning it can be absolutely anything. Let's again go to a world where people are trying to learn how to use this API. Is this going to be helpful? Is this going to be the fastest way for people to learn how to code graphics? I don't think so. I think if we want this for copy and paste down the road, if we want to build out kind of everything that processing has to offer using convenient readable APIs, and then offer this traditional layer on top for people who want to copy and paste, I think that's fine. But I think if this is the first thing we implement, it's going to take us longer to do the implementation. It's going to take a lot more testing code to catch all the possible error conditions. It's not going to be readable or understandable for people who are new to processing. For people who jump into the source code to learn what something does, it's going to be utterly unreadable. Compare what I have highlighted here to the implementation down here. It's a night and day difference. So my message here, again, to recap, is the angle I'm taking to begin with is to write short, readable, accessible implementations that do the same things that processing does, just in a way that people can more easily discover how to use it and discover how it works. But even after all that, even after we implement all of processing using these more readable APIs, notice that we can still come back and we can implement the traditional APIs on top of the readable ones. That's the order I'm doing things. If you disagree heavily, if you think that this is not going to lead to adoption, if you think this is going to prevent the project from being a success, by all means, go down in the comments below and make your argument and let me know what you think. But all things considered, I think this is the best in the interest of time and effectiveness. And again, it's not either or, it's which one's first and which one's second. So with that, the next few videos, they've already been produced. We're going to be just rolling through a bunch of these draw calls, things like, I don't know, squares and rectangles and circles and things. For a little while right now, the way these videos are going to work is going to be pretty much the same between all of them. We're going to pick one or two calls, we're going to implement them, we're going to write golden tests, we're going to move on to the next one. We're going to fill out as much of the API that way as we can, and then we're going to start figuring out what we need to engineer for things like animation support, image support, and at some point down the road, some notion of texture support. That's the direction things are going. As always, I welcome your comments, and I will adjust the order that I do things based on compelling arguments that you folks make down in the comments. So I'll see you next time.